Hi everybody, this is Chapter 11, Section 2, and in this section we're going to look at surface area of prisms and cylinders. Right, so a prism is going to be a solid where you have two bases, and you can see here, to find the surface area, you can find the sum of the areas of all the surfaces. Sometimes what they will do, think of it like if you have a cardboard box and you open up that box or flatten it out. So then we can find the area of the two sides, which are right here. And then front, I call it front and back, and then top and bottom. And then once you have the areas of all those, you add them together. It's called using a net to help you find the surface area. And here you can see they broke it down. They found for us the surface area of each piece. So the two sides, and then again, I call it front and back, and then top and bottom, and then they add them all together. So the total surface area of this figure or this prism is 72 square units. And we've talked about prisms a little bit, but prisms are polyhedrons. They have two congruent parallel faces that are called bases. So again, a prism stands on two bases. And like here's the base, here's the base, here's the base, here's the base. And then the other faces are the sides that hold up the bases. And they're called lateral faces. And you name a prism by the shape of its bases. So for instance, here I'm going to have the base has 1, 2, 3, 4, 5 sides. So it's a pentagonal prism. And then here we have a triangle for my base. So it's a triangular prism. The altitude of a prism is the perpendicular segment that joins the planes of the bases. So basically, think of it as like the height. So how far apart are the two bases? So here's our base, here's our other base, here's the height or the altitude. And again, the height or the altitude connects the two bases of the figure. We have right prisms here and oblique prisms here. We're going to talk about the difference of those in a second. All right, when you have a right prism, which is all that we're going to deal with in this section other than just mention oblique prisms, but if you have a right prism, the lateral faces are always rectangles. So the lateral edge is the altitude, and those lateral faces will be parallel to each other, the bases will be parallel to each other. In an oblique prism, some of the lateral faces are not rectangular. And again, we will always, in this chapter, work with right prisms, not oblique prisms. That's another section, and we're not going to deal with that in this course. If they ask for the lateral area of a prism, it's the sum of all the lateral faces. So think of it as the sum of those rectangles holding up the bases. And the surface area is the sum of the lateral area plus the area of the two bases. Right, so here they ask us to find the surface area of the prism. And then what I do is they say to use a net. Sometimes it's a little hard to draw. But what I do is I look at first the bases, because it is a prism and we assume it's a right prism because they said we're dealing with only right prisms, that the top and the bottom base will be the same. And my dimensions for the top and the bottom, they're rectangular, are going to be 4 and 3. So I'm going to say top and bottom is equal to 4 times 3, or 12 centimeters squared. Next, we are going to look at, we'll do the sides. So we'll do right here and right here. My dimensions are going to be 5, and right here I know this is going to be 3 because this is 3. So we'll do the two sides, and we do 5 times 3, and we get 15 centimeters squared. And that's for each side. So this is one side, and this is top or bottom, one of each. Next, we are going to look at the front and the back of the figure. So right here and right here. And my dimensions are going to be 4 by 5. So we'll do front and back. That'll be 4 times 5, which gives me 20 centimeters squared. Now to find my surface area, what you can do is you can do one of two things. You could take this, because I have two, top and bottom are 2 pieces, so it's really 12 times 2. 2 sides, so it's 15 times 2, for one for each side. And the front and the back, 2 sides. So I can do 2 things. I'm going to add the 12 plus the 15 plus the 20 together. And that is going to give me 12 plus 15 would be 27, plus 20 would be 47. And then I'm going to multiply that by 2, because there's 2 of each face. And that is going to give me 94 centimeters squared. That will be the total surface area for this figure. All right, you can use formulas for the lateral area and the surface area by using a net. If you have a prism and they ask you for the lateral area, to find the lateral area, you are going to do the perimeter of the base times the height. So you would do the perimeter of the base times the height of the prism, and that will give you lateral area. Surface area, you're going to do 2 times the area of the bases plus your lateral area, which again is perimeter of the base times the height. And again, just to reiterate, the surface area of a prism, any prism, you can find the surface area by doing 2 times the base, so the area of the base, plus the lateral area, which is found by doing the perimeter of the base times the height of the prism. All right, so here we are going to find the perimeter of the base, and then we're going to answer all these questions to help us find the surface area. So my base is right here, and I have 2 of the sides but not the third, but I do recognize that this is a right triangle, and the 2 legs are 3 and 4. So remember, your Pythagorean theorem can be used to find the third side. So if I do 3 squared plus 4 squared, it will equal c squared. I know that 3 squared is 9, 4 squared is 16. 9 plus 16 is 25 equals c squared. And then when I take the square root, c is going to be 5. So the perimeter of my base, if I add those 3 values together, 4 plus 5 is 9, 9 plus 3 is 12. Now they want the lateral area of the prism. So remember, it is the perimeter times the height of the prism. So the perimeter is 12. We do 12 times 6. And my lateral area is 72. Next, for C, which I'm going to do down here, they want the area of the base in simplest radical form. Remember, area of a triangle is 1/2 base times height, or it's a little b, not a big B. Let me erase that. It will be base times height. It's a right triangle, so my base is 3, my height is 4. So it's going to be 1/2 times 3 times 4. And I know that 3 times 4 is 12, and half of that would be 6 centimeters squared. So that's the area of the base. So now to do surface area of the prism, I need to do 2 times my base plus my lateral area. So we're going to do 2 times 6 which is going to get us back to our 12. And then plus my lateral area, my 72. So that means the surface area of this triangular prism, if I add 12 plus 72 together, it will give me 84 centimeters squared. Next, we're going to look at a cylinder. And a cylinder is a solid that has two congruent parallel bases that are circles. So they're not made up of polygons. It's not a polyhedron, but it is a solid still. The altitude of a cylinder is the perpendicular segment that joins the two bases together. So here's the altitude. The height of the cylinder is the same as the altitude. Again, we have right and oblique cylinders. We are only going to look at right cylinders. Here again is a picture of both. We have a right cylinder, which, the right cylinders are these two right here. The oblique cylinders are here where the bases are not parallel. We are not going to be looking at oblique cylinders in this class, only our right cylinders, so the bases will be parallel to each other. In order to find the surface area of a cylinder, really what I want you to do is think about, like, if you take a can that has a label on it, and do just what they described here. You really want to unroll the can. So when you take the label off a can and lay it flat, it's rectangular, so it looks like this, and then you just have the two circular tops to the can, and the circular top and the circular bottom. So to find the surface area of a cylinder, it's going to be the area of the round part, or the rectangular part, that think of it as like the label on the can, and we find that by doing the height of the can times the circumference, which is the same as our perimeter of our base, except it's a circle, and then plus the area of the two circular bases. Again, the surface area, you can do 2 times the area of the bases plus 2 times pi times radius times the height. And again, this 2 times pi times radius is the circumference times the height of the cylinder. It's the same for a cylinder as saying 2 times pi times radius squared, because that is pi times radius squared is the area of a circle, plus 2 times pi times radius times height, which is circumference times the height of the cylinder. All right, so here we have the radius of the base of a cylinder is 4 inches and the height is 6 inches. So they want to know the surface area in terms of pi. So I want you to think, here's our cylinder. And again, apologize for my drawing. The radius of the base of the cylinder is 4 inches. So the circle, it's 4 inches. And the height is 6 inches. So to find the surface area, first you have to find the area of each base. So they did 2 times pi times my radius squared, which is 4 inches. And they want it in terms of pi, so we're going to leave it in pi. 2 times 4 squared. 4 squared is 16. So 2 times 16 is 32 pi. So that's the area of the two bases together. Next, they did 2 times pi times 4. This is the circumference of the circle times its height. 2 times 4 times 6 is 48. When we leave pi, add those two together. 32 pi plus 48 pi will give us 80 pi for the area, the surface area of the cylinder. All right, so the last thing that we are going to do is find surface area without one base. So this is kind of cool, and hopefully one day we'll be able to see it. The Aquadome, or Dome, is located in the Radisson Hotel in Berlin, Germany, and it's the world's largest cylindrical fish tank. So it stands 82 feet tall with a radius of approximately 11 feet. And they want us to find the surface area of the tank without the top base, because as you can see, the top is not covered. And they want us to find the exact surface area and use 3.14 to approximate the surface area. So normally we would do for the bases 2 times pi times radius squared. But because I'm doing it with only one base, I don't need the 2. So I'm just going to do pi times radius squared. My radius is 11, so 11 squared times pi will give me 121 pi. And then we have to figure out the surface area of the walls holding up the two bases or the cylinder. So that is going to be the circumference. So 2 times pi times radius times the height. And we have 2 times pi times the radius of 11 times 82, which is the height. If I do 2 times 11 times 82, I end up with 1,804 pi. If I add the two together, my exact answer is going to be 1,925 pi, and that would be feet squared. Now, they want approximate 2, so I'll take the 1,925 times 3.14, and when I do that, it is approximately 6,044 and 5/10 feet squared for the surface area of the tank. And that is, again, without the lid. That's why we didn't do the 2, because we only used one base, so it was without the lid.